integral of r e to the r over 2 dr. Okay, so I look at this, and one thing that I might immediately do just to make this look a little bit more comfortable for myself is write this as r e to the 1/2 r dr. And that's just a personal preference. That's totally up to you. All right, so Andrew, you looked at this problem, and what did you think of your response?
I did not have a clue.
Okay, so you looked at it and said, I don't know what to do with this. Okay, great. So I look at this again, and my first thought is I kind of cross my fingers and say, I really hope that a u substitution works. And what would it be? A reasonable choice for a u would be this exponent up here for a u sub. And so I'm putting this in sort of a thought bubble over here because I'm not going to end up doing this. And so if I think of this as a u sub, my reasonable choice for the u would be 1/2 r, because that's the exponent, that's the inside function. But then I think ahead a little bit, and I think about my derivative, du over dr is equal to 1/2, and that's not going to cancel this r out in the front. And so I'm a little bit sad about that, and so I cross off my idea of a u sub, because it does not cancel my r in the front here. And so then I say, okay, what other techniques do I have? Well, I am not allowed to separate because this is multiplication in here, so I cannot do the integral of r times the integral of e to the 1/2 r. That would be bad calculus. So we're not allowed to do that. Okay. So, all right, so I go back and I say, all right, new technique, integration by parts. Integration by parts says that the integral of u dv is equal to u times v minus the integral of v du. Okay, so in order to use this formula, what I need to do is to identify which parts on this integral are the u and which parts are the dv. So I'm going to make up my table, my u and my v, my du and my dv. And I'm going to choose my u in a different way than I do for u substitutions. U substitutions, rule of thumb is choose the thing inside the parentheses. Here, I want to go with my acronym, LIATE. So no logs, no inverse trig, but we do have an algebra. And so the algebra is this r here in the beginning. So that's my u. And the remaining portions are e to the 1/2 r dr, and that will be my dv. All right, any questions about those choices? Okay. So now I've got this work on my side over here. My derivative of r is 1 dr. And this antiderivative, to go backwards, when I think about taking the antiderivative of e to the 1/2 r, what I'm really thinking about is integral of e to the 1/2 r dr. And there's actually going to be a u substitution to do this antiderivative. So when I look at this e to the 1/2 r and want to find its antiderivative, I'm going to let u be equal to 1/2 r. And my du over dr will be 1/2. And so in that case, dr is equal to 2 du. Okay, so working on this e to the 1/2 r, I can rewrite this as the integral of e to the u times 2 du, and I can pull that 2 to the front. Take my antiderivative, and I end up with 2e to the u plus c. And I can turn that back into r's, 2e to the 1/2 r, and then a plus c. So what's happening here is I've taken my antiderivative, and I've got 2e to the 1/2 r as my v. Are there any questions about that antiderivative there? By the way, if you do 552 of these, where you have e to the number times r, and you take your antiderivative, what you'll find out is that the antiderivative is 1 over the coefficient in front times e to the whatever times r. And so this pattern is going to happen every time. So after your 550-second u substitution here, then you'll be able to do that just bam, like that. Okay, so now we've got all of our parts. We can go back to our integral. uv r times 2e to the 1/2 r, that's our v, minus the integral of v 2e to the 1/2 r du, which is dr. Okay. So I've now written this down. I've taken care of this u and this v. If anything, I might clean that up a little bit, but I don't have to. 2re to the 1/2 r. And then what I always want to make sure 100% of the time is that I've cleaned up this leftover integral before I try and integrate again. I ask myself, is there anything I can simplify, anything I can cancel? And the answer is, well, there's nothing I can cancel, but I can bring that 2 in the front. Integral of e to the 1/2 r dr. Okay, questions or comments? Perfect. All right, so now I've got the integral of e to the 1/2 r dr, and I say, oh, I've got to do a u substitution on the 1/2 r, but you know what? I've already done that work over here, so I can use that same exact work that I did over here, and I know that this integral is equal to 2e to the 1/2 r. And so in the end, when I clean this all up, I've got 2re to the 1/2 r minus 2 times 2, so I've got 4e to the 1/2 r, and then a plus c at the end. All right, any questions about that one? Andrew, did that answer your question? All right, so then we've got 7 and 9. Okay, so 7 and 9.